So the next section we're going to talk about is solving one-step equations with multiplication and addition. So we talked about this in the last section. We need to remember that equations show that two expressions are equal or balanced. And we can also think of equations like these balance hangers or like the equation mobiles that we worked on in a different website. We can use different tools to help us visualize these equations. So if we look at this little balance hanger right here, it says one side is 12 and one side is made up of two shapes that we're calling y. So if these are balanced, that means the middle represents an equal sign. And we know that the left side is worth 12, and we know that the right side is worth 2 of something. So we can represent this 2 of something, 2 of y, as 2y. And now we have an equation that has multiplication. So just like kind of a little refresher, we can use inverse operations to solve for an unknown piece of an equation or a variable. And inverse operations are an operation that undoes another operation. So like addition and subtraction, those are inverse operations, and multiplication and division are also inverse operations. So for example 1, it says negative 2y equals 28. So first we have to figure out what operation is being used. Well, when it says what operation is being used, it's basically asking what is being done to the y, because what we're trying to do is we're trying to get y by itself. We want to isolate that y. So we have a negative 2 that's being multiplied by y. So multiplication is the operation that we're using. And then we need to perform the inverse operation to both sides of the equation. So the inverse operation of multiplication is division. So in order to solve for y, I need to do the opposite of multiplying by negative 2. I need to divide by negative 2. So the negative 2 divided by negative 2, that's just 1, that cancels out. And then y equals 28 divided by negative 2. So 28 divided by just 2 is 14, but a positive divided by a negative is a negative. So y equals 14 is our solution. And then anytime you want to check something when you're solving equations, you can take that value for y and plug it back into your equation. So our original equation was negative 2y equals 28. But I just found out that y equals negative 14, so I'm going to substitute that in for y. So when I do that, it'll look like this. Negative 2 times negative 14 equals 28, and then negative 2 times negative 14 is positive 28. So 28 equals 28, and that's true, we got the same number on both sides, so our check worked, and we know we got the right answer. For example 2, I have x over 5 equals 7, and x over 5 are a fraction. This is the same thing as x divided by 5. So for what operation is being used, division is our operation. And it says perform the inverse operation to both sides of the equation. So since the operation being done to the 5 is division, the inverse of division is multiplication. So in order to isolate the x, or to solve for x, I have to do the opposite of dividing by 5, so I have to multiply both sides by 5. So multiplying the left side by 5 undoes the dividing by 5. So let's just kind of cancel each other out. So on the left side of the equal sign, I'm just left with x. And then 7 times 5 is 35. And then when I want to check, I need to take that 35 and substitute it back in for x. So my original equation was x over 5 equals 7. I'm going to take my x equals 35 and substitute it in here. So that'll become 35 over 5 equals 7. And then 35 divided by 5, or 35 over 5, that just means divided. So 35 divided by 5 is 7. Equals 7, and we got the same number on both sides of the equal sign, so our check worked, and we know that we got the answer correct. So for these 4 practice problems, this would be a good time to pause the video and practice on your own, and then play the video when you're ready to check your answers. So for number 1, negative 7x equals 63. So the operation that's being done to the x is I'm multiplying it by a negative 7. So in order to undo multiplying by negative 7, I need to divide both sides by negative 7. So dividing by negative 7 undoes multiplying by negative 7. So on the left side, I'll just be left with an x. And then 63 divided by negative 7. Well, 63 divided by 7 is 9. And then because it's a positive divided by a negative, my answer is negative. And then if I want to check, I need to take that x equals negative 9 and substitute it back into the equation. So for my check, it'd be negative 7 times negative 9 equals 63. Just substituting in negative 9 for x, and then negative 7 times negative 9, that's 63, equals 63, and we got the same number on both sides of the equation, so our check worked. So our solution is x equals negative 9. And then for number 2, we have 10x equals 5. So the operation that's being done to the x is being multiplied by 10. So to undo being multiplied by 10 or multiplying something by 10, I have to divide both sides by 10. So multiplying by 10 and dividing by 10 undo each other. So on the left side, I'm just left with x. And then I have 5 over 10, or 5 divided by 10. So I can't divide 5 into 10 evenly. It gives me a fraction. But I can reduce this fraction because both of these numbers can be divided by the same number. So because both 5 and 10 can be divided by 5, I'm going to do that in order to reduce the fraction. So when you're reducing the fraction, you want to divide both numerator and denominator, both top and bottom, by the same number in order to keep the fraction equivalent or the same value. So 5 divided by 5 is 1, and then 10 divided by 5 is 2. So my final simplified answer is x equals 1/2. And then if I want to check, I just need to take that x equals 1/2 and substitute it back into the original equation. So that would look like 10 times 1/2 instead of times x equals 5. And then anytime you multiply a number by a fraction, if you want, you can make that number, or a whole number, write it over 1, and then see what you can cross cancel. So with cross canceling, you just have to be able to divide the numbers by the same value. So like for 10 and 2, I can divide both by 2. So the 2 would become a 1, and the 10 would become a 5. So then this left side would become 5 times 1 equals 5. And then 5 times 1 is 5 equals 5, so my check worked. So the answer 1/2, x equals 1/2 was correct. And then for number 3, I have y divided by 8 equals negative 2. So the operation being done to y is we're dividing it by 8. So to undo dividing by 8, I need to multiply both sides by 8. So multiplying by 8 undoes dividing by 8. So I'm just left with y on the left side of the equal sign. And then negative 2 times 8, well, 2 times 8 is 16, and since I have a negative times a positive, my answer is negative. So y equals negative 16. And then I can check it by taking that negative 16 and substituting it in for y. So negative 16 divided by 8 equals negative 2. And this negative 16 divided by, or negative 16 over 8, it just means divided by. So 16 divided by 8 is 2, but since I have a negative divided by positive, my answer is negative, so I end up with negative 2 equals negative 2. I have the same side, or the same number on both sides of my check, so it worked, and I know that the correct answer is y equals negative 16. And then for number 4, 9 equals a divided by 5, or a over 5. So the operation being done to the a is dividing by 5. So to undo dividing by 5, I need to multiply both sides by 5. So when I multiply the right side by 5, multiplying by 5 undoes dividing by 5. So those operations undo each other. So on the right side, I just have a, and then 5 times 9 is 45. So my solution is a equals 45. And then if I want to check my work, that a equals 45 has to get substituted back into the equation where a is, so up here. So my new check equation would be 9 equals a over 5, but instead of a, we're going to substitute in 45 over 5, and then we'll bring down the 9 equals, and then 45 divided by 5 is 9, so I ended up with the same number on each side of my equal sign, so my check worked. So my solution to number 4 is a equals 45.